Hey everyone, and welcome to our weekly Soroban design discussion. It sounds like Justin has some AV issues, so I think we're gonna get started without him. Today we have two main topics to discuss. There is metadata and there is changes to the token interface. I think we're just gonna jump right into it with metadata. Sid, are you gonna take this?
Yeah, yeah. So, um, you broadly, metadata is just static data that can be read by consumers without um, calling a contract function and invoking a WASM VM. So there are two levels of contract metadata. One is the code metadata, right? Because in Soroban we have this concept of these code entries that have, that contain WASM, and then we have instances that are tied to specific contract IDs, and those instances will also have some metadata tied to them. So for contract metadata, our plan is to put the metadata into a WASM custom section and just add support in the SDK to allow for this. So for example, you can when you build a contract, the SDK can put in uh, like build related information. The questions we still need to answer are more around instance metadata. So the easy option is to not add any explicit protocol support, instead have an ecosystem standard on how metadata should be stored in contract data. So whoever creates the contract can follow the standard and just put certain information into this entry, and users will know where to look just based off of the standard. And the SDK we can build tooling in the SDK to allow for this. Um, the one question here is how would paying rent on this entry look? Because this entry is not expected to be accessed on chain. So if there are no accesses on chain, then it'd be very easy for it to expire. So one solution to this is we could provide a mechanism to tie the contract instance to any contract data keys that the contract developer wants. So whenever you pay rent for the instance, it would also pay rent for those keys that are attached to it. That's one option. And then another option for instance metadata is to include an explicit metadata field in the contract instance. And the contract developer can write into that. This still only standardizes where metadata is stored, not how it actually looks, like in the protocol. But this would also, if we do this, we can also allow contracts to access metadata for other contracts without calling it to a WASM VM. Like we could expose that information because right now contracts are not allowed to look at data from other contracts without calling into a WASM VM. Like if you have to go through a contract function, so you have to go through the interface of the contract. We could instead allow contracts to just load directly the metadata field from another contract instance, allowing you to look at the information. Like for their example, in the token, you can look at the decimals or the token name if you want to without calling a contract function. So yeah, that's the one thing we're still thinking about for metadata. But I think that once we figure that out, we should be able to move forward on this. Any questions?
What are some examples of scenarios in which contracts need access to other contracts as metadata?
So it's not this won't be like a common scenario, but if a contract wants, say, the token's decimal number for some reason, right? We expose that in the token interface, right? We have the name, the decimal function, and the token function. And we did that because there is no other way to get that, right? Because we don't have metadata right now. But if a contract wants that for some reason, right, this would be a way to get it. I don't think I don't think we need to optimize for the scenario where you want to call into metadata in a contract without calling through a contract function because it will be rare. And because of that, it's fine to expose that in the interface and call into a contract function. But yeah, that's one example.
Yeah, but I'd love to learn about like concrete uses for this because it looks like all the metadata uses that we've been discussing are mostly for downstream systems. It's not for other contracts to consume. And if that's the case, then I definitely agree that having just a standard metadata, ledger entry and a way to access it is kind of like makes the most sense for everyone. The question is like, are we losing anything? Are we losing like this important optimization here?
So
Go ahead, Dima.
yeah, I'm looking at the Oracle Consumer Interface precept thread on the store dev. I don't know if everybody has seen it here. But basically it tries to come up with a standardized Oracle interface, and it has a bunch of functions like base asset, with a list of supported assets, decimals resolution, that I suspect may be useful when used on chain for the Oracle users. Correct me if I'm wrong. I think modes and orbitlens are here. So yeah, let me know what you think about contracts like that, where like it seems to me like these properties seem to be useful for some on-chain operations, and optimizing these cases would be generally beneficial.
If we are talking about the Oracle contract interface in particular, I think that we need to define the validity of those values. For example, if we expose decimals and other, let's say, static properties of the contract in the contract itself via methods in the interface, all other consumers can pretty easily fetch this data. But for all other options, I don't see that it will be as optimal. For example, if I understand correctly, contract code can be upgraded, and in fact, during the upgrade, we can lose those values, or they can be replaced with some other values. So from what I'm seeing right now, I don't like see any benefits from providing some external access to this metadata in WASM or contract ledger entry or data ledger entries, and definitely it shouldn't be in Stellar TOML, because Stellar TOML is bringing the logic outside of the system, and it really has a lot of problems in terms of usage from the consumer perspective. If we are talking that Stellar TOM is one of the options on the table, then we can just expose these static values on the project website, and that's it. Because even in that way, it will be probably more reliable than using Stellar TOM.
Yeah, I don't think Stellar TOM is on the table. So my question is rather like, what do you think as a user of an Oracle contract, for example, as a contract user, that is, would you be ever interested in calling functions like base asset or decimals or list of assets? I see Moods has posted on the chat that contracts are expected, for example, to fetch decimals from tokens, which might be the case as well, right?
I think it's probably like one-time only calls, because most of these methods, functions you mentioned, they are actually static, right? But anyways, I think that for consistency, they should be there. If we can, for example, expose some of these values in WASM custom section, etc., that's good. But still, I think the easiest way, from the perspective of downstream systems, is to just pull this information directly from the contract via the contract function call. I think it's possible to come up with some special cases where this where these functions will be called like much more regularly. For example, if there is some proxy contract that aggregates data from, let's say, a dozen of different oracles, then these functions can be called, for example, on every access to the underlying systems. But I don't really see whether other like storage options, for example, contract ledger entry, will be better than contract call in this regard, because it's more flexible.
I mean, it's more flexible and less efficient, right? If you need to make n+1 or n+2 contract calls instead of n, you are spending quite a bit of gas on that. So I guess Tomer's question was whether we ever need this data on chain. It seems like yes, at least sometimes. Just to explain where I'm coming from, I just feel a bit of disconnect that a lot of the contract interfaces expose a bunch of this metadata-ish functions, and they're usable both on-chain and off-chain, and it's not really efficient to use them either on-chain or off-chain, which I would consider a slightly an argument towards having this instead exposes static metadata that is readable by anyone, writable by the owner contract. But I don't have a strong opinion on this, but it just feels weird to me that we have a bunch of these static contract methods that are kind of tied to the contract instance, and they will always just fetch an entry from the ledger. It seems like an easy optimization for me, but I don't feel like it.
So it sounds, Dima, like what you're suggesting is like a step towards, basically like exposing kind of like API by shared memory, which I think for like non-metadata use cases is a bit dangerous. Like maybe the contract shouldn't actually expose data through like a shared memory structure. And if I look at the functions right now, especially on in the token contract, they're mostly there for downstream systems. And I did want to ask Moots, can you give us examples of when other contracts actually need the decimals? That sounds a bit idiosyncratic to me.
Yeah, I guess probably the best example I can think of is in any system that has to attempt to value some collection of tokens that may or may not be fully defined and or can change in the future. An example of this would be Aave. Aave at any point in time in the future can choose to add a new token. They probably don't want to assume that in the Ethereum case, all tokens have 18 decimals. For example, they have USDC, which I think in Ethereum only has 6. So in that event, if you are trying to consume some common price to compare all these assets in, you'd have to take the decimals into account. Otherwise, your price would either be severely inflated or deflated based on whatever number of decimals you've been assuming. So that would be kind of like I suppose trying to value some set of tokens would be really the only case I can think of that decimals would be needed on chain, but it's a fairly common one.
And Aave actually does that? It calls the decimals function?
Yeah. Some people for example, Balancer does something kind of interesting where they actually normalize all the decimal values and just assume they're 18. Which is an option too if you want to avoid trying to call decimals, but just because oracles don't always list prices in normal the same denomination, you would need to use decimals to ensure that you're actually getting the correct one.
Got it. So it's mostly kind of like normalizing data coming from oracles.
Correct. Yeah.
Yeah, it just feels a little bit weird to me that like the functions for Exet are metadata conceptually, right? And it is weird that we expose it as a function, but we are not going to use it on chain, whereas we are proposing just, hey, let's use some standard, like we have this ledger entries with the metadata to use off chain. So you see what I mean here? So basically we have functions, but we don't use them on chain. And then for off chain, we have standardized metadata entries. Then there is a question like, why do we even expose this as functions in the first place? Or maybe vice versa, why we bother with defining the standard structure for metadata at all if we provide functions for that? We say like, hey, just if you want to expose any metadata, expose it to this as a static function. It's hopefully reasonably cheap to call off chain anyway.
Well, I think the answer is we expose functions today because we don't have the concept of metadata, right? So the question is like, if we do have the concept of metadata, then we will probably reduce the number of functions to those that are actually usable on chain. And things like the name of the token probably not usable on chain. I don't see a reason to expose that. So, like I would err on the side of like not introducing new mechanics than introducing new mechanics. And whatever we can do with defining ecosystem standards is better than making protocol change that we need to live in forever.
Yeah, definitely. Like I'm all for like letting more stuff to be resolved, like off protocol, off chain. Just that it's a little bit weird that we have two ways of doing the same thing. But if our guidance is, hey, like if you don't ever expect this to be accessed on chain, just use a ledger key. Don't blow out the interface, and I think that's probably good enough.
Yeah, and I do think it's an optimization for downstream systems, right? Like we don't want wallets to like constantly be calling, running like WASM code to determine like decimals and asset names.
I think that if we are going with any of the let's say with any static storage for this metadata, it should be read-only. So it's like it's set for once and never changed because otherwise from the consumer perspective, I don't really understand when this data can be updated, for example. And anyways, if it's stored not in the contract data, but in contract ledger entry or somewhere else, I think that in most cases, consumers will have to do it like every time. I understand that it's cheaper, but still, if we are decoupling this from the standard contract storage, it probably makes sense to ensure that these values are read-only. For example, if they are created in contract ledger entry, then they should be created during creation and then never changed.
So that's an interesting point because we will allow for updating contract instances, or sorry, you update a contract instance to point to a different contract code entry, and now I think ideally you would update in a way where the metadata still holds true, but
yeah, it's completely decoupled. Like no matter how metadata is stored, like we shouldn't touch it when the source is being updated. And to be clear, the sort of metadata we've been talking about that is attributed to the WASM source, this is not like the data about like decimals or anything because it's not an instance data. It's more like this has been built with version of SDK X, or this implements interface Y, and not more than that. So, when we update it, yes, it will be updated, but like it is expected. Like when we update it, yes, it will be updated, but like it is expected. Like if the implementation migrated to a new SDK version or a new standard interface, I think this is what you want to observe.
You're talking about code metadata, right? I thought.
Yeah. But I think there was a question about like, hey, what if we update the contract implementation? So what I'm saying is that you do not touch instance metadata, and the code metadata itself is expected to be updated because it just describes the code. So.
But do you allow for updating the instance metadata? I get the code metadata.
It depends. It depends on the approach, right? If we go for the contract storage, just in normal contract data ledger entries, it is updatable. And the same is true for the current functions it exposes, right? Like nothing prevents you from changing the token name currently. If you go for another approach, we can make it read-only if you want.
Okay, because I think that's what Orbit just brought up. Okay, so it doesn't sound like we've like decided on, if this information. So like, we can actually. Someone mentioned that the metadata, we don't have metadata at the moment, but technically you can still look at the token and figure out where the balance entry, where the decimal entry is stored, right? And what we're saying is, if you do this all off protocol, then we would just figure out a ecosystem standard for where the decimal entry will be stored, because they'd already exist today. We would ideally put decimal name and token all into a single metadata entry. That's like determined by the ecosystem, not by the protocol. Right. So it's not like we're going to add like a new concept of like a new type of entry, or add information that doesn't exist today. It's more about where we put the information that already exists on chain today, and just in a way where we can where it's easy to retrieve. Right.
Yeah, and if I try to paraphrase what Dima said earlier, at that point, I think that the argument here is like not whether or not to add this to the contract entry itself, but assuming that we're not, like, do we actually need to standardize this, or do we just use what we have right now, which is functions, because like more ways to access data is like more dangerous, or it creates like a bifurcation there.
Yeah, and that's specifically for the like your question is specifically about the cross contract case, right?
Yeah, it's just
I think the cross. To be clear, I think the cross contract case is actually like I recognize that there are use cases for that, but I think they're like fairly minimal. And I think most metadata that we've been talking about is never going to be consumed by another contract.
Yeah, I agree.
I think we need to consider the separation of security for these two values. Let's say if we talk about the value that is stored and modified by the contract itself, then the security lies entirely in the field of the code written by the developer. But if we introduce another way to store some metadata, would it be read-only or some other, let's say, editable metadata, we need to think about security considerations here as well. So we need to provide information and strictly define when it will be changed and under which conditions. Because again, if we are talking about Oracle's price, modifying the decimals may have like disastrous effects for all consumers.
Orbit, I didn't understand from that what your perspective is. You said if we're introducing a new mechanism for accessing metadata, do you think we should introduce like a separate mechanism for accessing metadata?
I think we can introduce, and it's okay, but we should define very strictly under which condition it changes. So there are like a few options described in the pre-read doc, and we should probably focus on these options that either provide read-only access to this metadata or at least provide strict security guarantees that this metadata won't be changed by someone in the runtime. Because contracts, for example, can have other more strict security guarantees than the deployer contract or deployer account, for example. It's something that should be considered.
The more we talk about this, the more I feel strongly that we shouldn't introduce like a protocol feature specifically for this. And I think that the functions, the cross-contract calls facilitate all of our on-chain needs. And an ecosystem standard for metadata can help downstream systems just know where something is instead of calling for it. But I don't think we should introduce new protocol mechanics here.
Yeah, and to add to the concerns that Sid has mentioned at the very beginning regarding the rent payments for these entries that are never going to be attached on chain, supposedly, I think that the current iteration of the rent proposal kind of takes care of that in a less reasonable fashion, because you can bump rent on arbitrary entries. So, if you really care about your token contract, you can just bump the rent on its metadata every once in a while. And the good thing is that metadata is not like something that has to be there to make your contract operate. So not critical to maintain rent on it, but it will be possible. So it's not a concern as well.
Well, it does have to be a manual process, though. And so I'm wondering, like, if it would be wise to maybe somehow tie the metadata to the contract instance itself. Because right now, you currently have a rent bump whenever you access either read access or read write access. And so I can imagine a scenario where, like, the contract is used on chain a lot. But then, if you don't manually call this bump, then even though it's being used on chain, the metadata can get archived and default on rent. So I'm wondering if we should tie metadata somehow to the contract instance such that if the contract is actively being used, the metadata won't get sent to the archive. You don't have to have this manual intervention.
But Garen, isn't this problem relevant for any like global state that a contract has? Like, this is not something unique for metadata. Even like like pool values in a liquidity pool will need similar mechanisms, no?
This is true, but I feel like metadata is just somewhat unique because it's just never used on chain, right? And like if I feel like for most contract data types, if they're being touched or if they are like relevant for on-chain operations, then they'll be accessed and they'll have the rent bump. And so I feel like that's like the one issue with the metadata is that because it doesn't have an on-chain use, it will never have this automatic bump because it should never be accessed by an on-chain contract.
That's a good point.
Because like in the liquidity pool thing, like it will be accessed, so it will have this automatic bump. And so I'm just worried that, it's like a weird interface where we have like essentially, especially in the new rent proposal where we have automatic rent payments. It just feels weird that rent is paid automatically for, anything that's relevant, but a very popular contract instance would still not automatically update the metadata entries. And so it just feels like a poor user experience.
Well, I mean, in the current proposal, right, you still can bump rent manually, right, for any ledger entry you want, which is what I refer to by saying that we have a solution for that. I'm not saying it is perfect, but since we say that, hey, this sort of metadata is for the off-chain usage anyway, I don't see it as too offensive that you need to craft the rand bumps off-chain as well, as opposed to the automated bumps. I mean, yeah, it's probably not the best UX, but it seems like the cost of defaulting a rent is really low here, and not impossible to recreate this entry if needed from the archive. So I feel like, while it may be of a minor annoyance, it doesn't seem like something super critical. But I mean, you can also get creative and do the merging of the data that is being accessed on chain and that is purely metadata, just by implementing it in a certain fashion in the contract. Like you can have a single entry that mixes both used and unused data, and then everything will get bumped together, which is what I guess we have agreed, like this can be developed off protocol if needed.
Yeah, like my general sentiment is if this if this thing is still alive, there will be at least one entity that that cares enough to put quarters in this meter.
Okay, so it sounds like where we are at the moment is that the metadata won't be exposed directly on chain, and we will say for now that rent will just be manually bumped on these entries. Is that right?
Yes.
Okay. All right. I don't think there are any other questions around this. So we can, if no one else has any other questions, we can move on to the next topic.
Yeah. So the token interface, I don't have much docs for this, but basically there is a couple of things that we haven't still done with the token in the light of what's next. And some of these things are pretty non-controversial, I think. Like, for example, all the admin interface doesn't require admin address anymore to be passed to it because we need to fetch admin from the storage anyway. So we can directly call require auth for it. The next thing that is slightly more controversial, I guess, and interesting is this auth next. It is much easier to make outright subcontract calls on behalf of someone. So you can, the user can call a contract that calls token transfer, for example. And it is a useful feature, but regular transfer is quite limited in the sense that you can only send a preset amount, and this is the exact amount that you have signed. So if for example, if you have some trading contract that doesn't perform a full trade, it will need to come up with a custom refund logic, for example, like if the price has dropped down compared to what you have authorized. And for that cases, we want to introduce a function like X for max, or maybe X for contract. That in proposals are welcome. And this function would basically allow signing as maximum amount and signing the address that is authorized to transfer up to that amount. But then the call itself accepts the actual recipient and the actual amount that, of course, have to be not exceed the amount that has been signed by the user. That allows to do something like the user has signed transfer of 100 XLM, and during a trade we figured that actually they need to spend just 95 XLM to perform the trade. So the contract can do just a single token call xfer max with 100 XLM authorized and 95 XLM as actual value. So I guess interesting question. Like the proposal like that seems reasonable, at least from the previous discussions. I guess the question for this particular proposal is how many xfer functions are we going to have? Because currently we already have like 2 xfer and xfer from this using allowance, which is like the next topic. But maybe we should try conversion. For example, have the normal xfer behavior to be always like this xfer max I have described. Like you always sign the actual value of the transfer, but then like if you are doing just a simple payment, you can bypass the remaining arguments that duplicate them, something, and then you're calling it from contract, you can decide. Or we can have 2 functions. So I guess that is the question here. I'm interested in some opinions. So I guess the trade-off here is either more complex interface or simpler interface with less functions, but this function itself is like more complex.
So Dima, just to make sure we're all on the same page, in current semantics, if you want to do like a trade that is a strict send, then the current xfer function is enough, right?
Yes.
Okay. So if you want to do like a strict receive in which like the other side of the trade is guaranteed, then the like the send amount can be flexible.
Yes.
Got it. Out of curiosity, what is common in the world of popular AMMs on Ethereum, for example? Do they work on like strict send or strict receive semantics?
Idea? I don't know. Does anyone here know?
It's not really either, sadly. You kind of put in a price and you put in a slippage tolerance. So it's likely more. I guess, yeah, no, it's definitely strict send with the slippage tolerance.
Got it. But the amount you send is set.
Yeah, it's just the amount you receive is undefined up to some limit.
Yeah.
Do you think this is a function of requirements, or is this a function of the, for example, token interface and interface? Yes. Like I can see it either way, because I know that some things are definitely byproduct of the inherent design restrictions on certain blockchains. So I wonder if here this is really a business requirement, or just something that is a product of token having only strict sense.
Yeah, I hear you, and it is difficult to know. I this is anecdotal, but I can tell you that throughout the beginning of Stellar, we only had like strict receive semantics, and that was extremely confusing. And when we've added strict send, most people kind of like migrated to that because it is and this is an assumption. I think it's a bit easier to perceive, I'm gonna put this amount in, and I recognize that the amount coming out can be like dependent on market conditions. The opposite end, like the other side, I think is a bit more confusing to people. So I don't necessarily think that having only strict sense semantics is that bad. I am concerned about having an interface that is a bit convoluted and has too many xfer functions. By the way, can we please stop saying xfer and like move to transfer functions? Will that happen soon?
Yeah.
Yeah.
Actually, as a part of token interface discussion, I think we should migrate to longer function names. I know that we allow up to 32 bytes. I think we should call xfer transfer and rename all those terribly named functions that they're trying to fit into that character. So yeah, I think this should
Yes.
happen.
Yeah, I think in the chat everyone is excited about this. Yes, let's have more understandable, longer function names, please.
So the proposal here is just not do it at all and live with only a strict send transfer. Because it is true that it is not impossible to just like, even if you need strict receive behavior, and even if you don't use allowance, you still can do it by for a transfer of the whole amount and then refunding. So that's an option as well, and it keeps things simpler. And if we find this useful, we can extend the token interface eventually.
Yeah, especially because this is, we're not talking about just a standard token, right? This is the token interface, right? So this is, every implementer is going to have to implement this. And I do think that we need to as much as possible, keep it simple. And, say what you want about the ERC20 interface, it is fairly simple. And I think there's something to learn from that.
Yeah, I mean, that's an option too. Just that, like this whole thing came up during most next discussions, and it seemed like a lot of people were interested. Like, what if I need to send a volatile amount of token? But if that's really more of a hypothetical case, and in reality, it doesn't really matter much. And yeah, I agree that we can just keep interface simpler. So unless someone has a very strong use case for transfer max, let's drop it for now. Does everyone agree?
Yeah, any supporters of Transfer Max want to speak now? Okay.
And then the next topic is allowances, and yeah, I think there was some controversy about this, but basically what I'd like to have in the end, which we may not necessarily achieve, but I really think that things like persistent and unlimited allowances are inherently dangerous. And I mean, like there is some data about millions of dollars lost to persistent limited allowances on other blockchains. So I think there is some evidence that this is not the best pattern to use. But that said, like there is seemingly a pretty narrow slice of cases where it might be useful. It is still dangerous, but it could be useful, like the case of recurrent payment or subscription. For that cases, I think that using account abstraction is the correct quote-unquote solution, because it enforces the actual recurrence. Like when you are doing a recurring payment, the actual requirement is not I allows this contract to spend as much token on my behalf as it wants, but I allow this token to spend up to X token during the time period of n weeks or months or something, right? So the question here is, like, if we want to still have persistent allowances at all in the token interface, given that they come with certain risks. And another thing is, again, another proposal I had is just temporary allowance that exists only during the contract co-execution, and that's mostly useful for the cases similar to like strict receive, or maybe even something more convoluted than that, where you want to take the token from the user and spend it between several parties, for example. Again, I recognize that's probably not the most useful use case necessarily, and I have seen like there are concerns about the need for the temp storage at all, but I feel like, at least if you're talking about allowances, I would be much more comfortable with like temporary allowances, because the main issue is persistent allowances is that, well, people just forget about them, and then if the party that had allowance is in some way compromised, then you would lose your token without much action from you. Whereas like when we are talking about something temporary, it exists only within the scope of a single transaction. So yeah, basically two questions. Like, do you have any arguments pro and against persistent allowances in token interface? And if you have something against, or maybe for the temporary allowances at all, and then we can decide like what do we do, I suppose.
Dima, around this concept of like persistent using account abstraction instead of persistent allowances for things like subscriptions, can you like further explain how this might work? I don't fully understand that.
Yeah. So account abstraction allows you to basically do signature-less transactions. So instead of making like signing every operation done with your account, what you can have is that your account may have a function that you need to authorize that says, for example, add subscription or add recurring payment is whatever requirements that seem useful, right? For example, spend token X up to a certain amount within a certain time window, and may have certain options, right? How this time window is being applied. So I guess this totally depends on the business requirements of the payments, which is why like an alternative to that would be to do some timed approvals for the token, but it seems really complicated for something as simple as token interface, right? Because there may be different requirements for this. And to be clear, like recurrent payments is just one example. Like there are other examples where you can have a session or something. But anyway, so you have a function that says add a subscription, right? You authorize it and write an entry owned by your account to the ledger that describes this subscription. And then when someone tries to authorize something on behalf of your account, depending like with the arguments, maybe whatever your contract decides to do, but the point is that instead of verifying some signature, it would expect the code to have no signature at all, but instead it would expect a certain entry being present in the ledgers. For example, in case of the recurrent payment, it would expect that if a contract tries to call a token transfer on your behalf without any signature, then it must have a subscription. And then it would fetch a subscription from the ledger, verify that the send amount does not exceed the remaining balance for the subscription, and if so, it would allow it. What are the... Mhm.
Would it be fair to say the advantage of doing the account abstraction approach to subscriptions is it lets the code live in the actual wallet and be more complicated that way versus just being implemented as like an approval mechanism in the token, which is a bit dumb?
Yes, there are a couple of advantages. One is customization, like you don't need to touch the token interface and you don't need to restrict yourself to the tokens, right? You might also, I don't know, authorize some text to trade your NFTs or something. Like I'm making this up, maybe it's a bad example, but you get the idea. It's not limited to token and it's not limited to like a certain way of defining the time bounds, for example. And another advantage is that you are the owner of the account, which again, in case of the persistent allowances, for example, the allowance is delegated to a third party. You have no control over it, and if it's compromised, you're in a bad situation. Here, you will be screwed only if your account is compromised, but I mean, that's a general problem of any account. But at least you do not put any additional trust to the third party. Like you just define rules that for the third party to use your funds.
But
I mean, if you set up, sorry, go ahead, Tom.
Like for this, it sounds like you need special accounts that can actually handle the logic for like understanding the subscriptions, but also you're kind of like you're moving the responsibility of like the subscription logic from the merchant to the account. Like, what do we expect, that merchants are going to program accounts for users to do this? I'm a bit confused.
Yeah, that's definitely a general issue. While account abstraction seems like a nice idea, like in reality, we have already a ton of Stellar accounts out there, right? That I would imagine dApps would want to build for, which is why I'm not saying necessarily this is a only solution. I'm just saying that it is an architecturally good solution, and it's good from the security standpoint. And in order to kind of mitigate the issue of, for example, classic store account not supporting anything like that, I had another proposal here on Discord called extensible accounts. And what it comes down to is that you basically kind of can add delegations for your account to delegate authorization from your main account to another account. And think of it like as adding a module. For example, you can have a classic store account with subscriptions module. Obviously, someone needs to write this module account. Doesn't have to be merchant. It can be, one library that provides it. So it is a non-zero amount of work, obviously, but it is shareable as long as there are some standards like, hey, this module standard allows to do subscriptions, for example. And anyone who can or who wants to do subscriptions just needs to make sure the account has this module. Again, this is just a proposal I had, and I think it's also applicable to a more broad case of, hey, I want to do something interesting with custom account contracts, but I'm worried about onboarding. So these extensions, it is possible, you don't require a user to just migrate to your account implementation necessarily, but you just allow them to reuse their main account address, but benefit from some new features, which I think may be generally useful thing to have for adoption of custom accounts.
The extensible accounts thing is super interesting. I think it ties in really closely with contract upgrades because accounts are generally, really long lived, and you want to be able to upgrade, like if the subscription interface is a new thing, or there's like subscriptions v2, right? You don't want to be stuck with your smart contract wallet being on the previous version.
Yeah,
So it kind of ties in.
and I guess the good thing about it is it kind of allows for experimentation, because to be completely honest, I have my doubts about like general adoption of account abstraction. If you just say, hey, here are the store accounts, but you can also build your own things, this seems like a pretty daunting task. And if you can at least build things in a modular fashion, hopefully there will be more use for that. That said, I realize like this might be a separate discussion. Like if not everyone has read this proposal, I would feel okay-ish with just leaving the persistent allowance out there and adding a disclaimer about like don't use this unless you have to, as the simplest solution. But my stance is basically that ideally sooner or later we should just get rid of that and rely on account abstraction for that. It's just custom extensible accounts.
Yeah, it sounds like there's a tension here between like what is kind of like secure and has like proper architecture, elegant and like extensible, versus what is kind of like simple and generalizable, which is like what we have right now with the persistent allowances. My vote is to keep persistent allowances there, because if we're going to rely on people implementing their own account abstraction or account abstraction like modules for subscriptions, then I think that's a bit of a high barrier of entry.
I wonder how popular subscriptions are in general, and how comfortable are people with them, especially when it's done in the form of I just give an unlimited allowance to this contract. So I'm not necessarily convinced that this is like a super strong use case in general, but as I said, like if you add some disclaimers and say that like with OS Next and with our OS framework, whatever, you should be able to avoid this in like 95% of the cases. Probably that's good enough, because really the case in like why I started this topic at all is that in reality you shouldn't need allowances at all, like most of the time, right?
Yeah, I would say that subscriptions right now in crypto are definitely not there yet, but in the world of merchant payments, they're huge, and we can't ignore it if we do believe in kind of like wide adoption of
Yeah, definitely. But I guess the question is here rather like, would we want a simple but insecure solution, or should we rather strive for providing proper secure support?
And I don't think they're necessarily like mutually exclusive, right? If we do have persistent allowances and we come up with like a better mechanism to like auth abstraction, that's great. But I think just having something that is kind of like a simple catch-all mechanism is still worth having.
Yeah, it just means we need to support persistent approvals forever, and everyone that implements a token does as well, because it's part of the token interface.
Yeah. Yeah, which is for better or for worse, is an established practice like across
the
ecosystem, right?
Yeah, again, coming back to the question of requirements versus limitations, I'm reasonably certain that persistent allowances are a result of the limitations of Ethereum, right? As reliance on a single single signer and the single call, right? They really are not needed most of the time. So my main concern would be really not about the subscriptions necessarily, but about just people misusing allowances out of habit. Again, they are not needed most of the time. I think that's an important point about Soroban, right? You shouldn't need allowances, and they are generally bad. So, but I mean, as long as you can make this clear, hopefully that's okay.
Yeah, I definitely agree, and I think that both in the documentation and in wallets that implement signing these, there needs to be kind of like huge big red warnings whenever you actually sign an allowance, because users shouldn't be doing this on a regular basis.
Yeah, as long as we say that this is reserved for some specific use cases.
But
Great,
yeah,
so-
I agree. Sorry, go ahead, Tom.
No, you go ahead, Bob.
I was going to say, yeah, I agree. The smart contract subscription model, or smart contract wallet model for that is definitely better, and it's nicer. But it opens a huge can of worms, in particular around like you've approved. With the approval model, you could say to the user, you've approved this amount for these wallet transfers, right? Which is kind of easy to understand. But if you're getting into like more advanced logic within the smart contract wallet, that's a big UX challenge to explain that to users in a way they can understand, which like we're not going to solve in the next 6 months, given everything else we have to do.
Yeah, I mean, that's definitely like that's the thing, right? There is some upfront cost before we get nice things. Yeah, I'm not sure if people in the community are looking into that. It would be really nice to build on top of this kind of abstraction framework, but yeah, I definitely recognize that it is a pretty high entry cost, right? Because we need both wallet support and on-chain support for that. So yeah, not sure how we will proceed with this.
So it looks like we're on time. I would say I think for now it sounds like we're leaning towards keeping persistent approvals, persistent allowances, and we probably need to further discuss the idea of temporary allowances. But we'll push that to next week. Cool. Well, we're out of time. Thank you so much. Have a great day, y'all. See you next week.